We'll now look at our first method of inference, which is confidence intervals. So the idea with a confidence interval is we know something about our sample, and we want to make conclusions and try to figure out exactly what we can say about the population. So the basic idea of a confidence interval, it's an interval or a range of values that we use to estimate the parameter. So like I said, we know something about the sample, and then we find this range that we think contains the parameter. One of the big things to note is that this estimate may or may not contain the true value. These are just an estimate, and it could be that we're wrong. Fortunately, we'll be able to give kind of an estimate of how wrong we may be. So let's look at how we would actually go about finding this and exactly what it is that we're doing. In order to calculate one of these, we need to know a couple of pieces of information. The first thing we're going to need to know is the sample mean. In reality, we need to just know a sample statistic. It could be the proportion or the mean or lots of other things. But for now, we're going to restrict our focus to confidence intervals around a mean. So we need the sample mean. We're also going to need to know the sample size. When considering the sample mean, we're also going to need the standard deviation. And finally, we're going to need to know the confidence level. One other thing that we will need is we do need the central limit theorem to hold. So it does need to be normally distributed or a sample size greater than or equal to 30. Because the central limit theorem is holding, that we know the sampling distribution will be approximately normal, so we will be using the normal curve. We're essentially going to put the sample mean x bar right here at the center. The sample size and standard deviation help me define exactly which curve it is that I'm looking at. And then my confidence level is going to be something like 90%, 95%, 99%. So essentially what we're doing is we're going to form this little range around the sample mean. And the area inside of here is my confidence level. So let's say, for example, 95%, which will be the most common. We do want to build this symmetrically. So there's 5% left over. So there would be 2.5% in this right tail and 2.5% in this left tail. So essentially, like I said, we build a 95% range around the sample mean so that the normal curve holds 95% of the data within this range. We'll call this value z. This one would be negative z. And when we calculate a 95% confidence interval, essentially what we're saying is there's a 95% chance that my population parameter, the true mean, is somewhere in between this range. So how do we actually go about finding that? There are going to be lots of different confidence intervals we can calculate. For now, we're going to restrict ourselves to the most basic one. We're going to assume we're building a confidence interval for a mean and that we know the population standard deviation. And here's my actual formula for the confidence interval. There are two things that we're calculating. So we see is something on the right and the left. The middle is what we're actually trying to find, mu. So you'll notice the difference between the right and the left is just one side is subtraction, one side is addition. So we have the sample mean on both sides. We're either going to add or subtract. This z value comes from my confidence level. And in my previous picture, we showed the z's. That's where these come from. It's the actual numbers that would hold 95% of my data. And then we do the population standard deviation divided by the square root of the sample size. For us, we're actually going to get calculators to help us with this. In particular, we're going to use the GeoGebra Graphing Calculator app. So the command for that would be z, mean estimate. We then enter x bar, our sample mean, sigma, our population standard deviation, and the sample size, and CL stands for confidence level. How confident do we actually want to make this?